Now next one is Finfet. So we are going to go for the next type of device called as Finfet. Okay, see, these two topics are actually a part of Unit 3, but they are given in book as a part of Unit 4, so I am teaching it here. But actually, module gate MOSFET and the FinFET are part of Unit 3. Please remember that. I'll try to change that in PPT so that you will not get confused. Okay. So in many MOSFET devices, in addition to the usual gate form, there will be another gate at the bottom. See, conventionally in MOSFET, you see you will have two gates and you will be shorting both the gates. So, okay, but the gate which is at the top is usually going to be called as the front gate, and the gate which is at the bottom is called as the back gate. The back gate, both the gates will control the channel potential. The typical back gated structure is shown in 4.23. So, you can see here, conventionally, the substrate will be considered as another gate. So, we have seen in all the MOSFETs, you will be writing this as G, you will be writing this also as G, and you will be shorting both. If you see, look at the earlier MOSFET diagrams, can come to a conclusion. You'll be shorting both. And this terminal, which is visible along with the source and drain, is called as front gate. And the terminal which is available at the back, at the substrate, is called as back gate. So that convention is usually followed. So you can see that it is actually a dual gate. So actually, conventionally, MOSFETs are dual gate, but specifically, if I'm going to create one more terminal for gate, then I call it as dual gate MOSFET. So you can, in dual gate devices, it has an excellent control characteristics because I have the two voltages which are available to control my drain current. Okay, so the two gates will tend to shield the source region from the action of the drain, providing a very high degree of isolation between the source and drain. So as a result, short channel effects are reduced. What they are saying is, when you have two channels, when you have two gate terminals, they are going to isolate source and drain in such a way that I will not have any issues with the channel present inside the device. I can eliminate short channel effect inside the device very effectively. Okay, so when you are going to use the gate terminals properly, when you are going to properly short them, they say that gate is present in between source and drain, right? So this gate terminal is going to provide a proper degree of isolation between the source and drain, thereby reducing all the short channel effects. The reduction of short channel effects can be obtained by having a fully depleted SOI between the two gate electrodes connected together. So you are going to have a silicon on insulator device. SOI is silicon on insulator device, which is going to be, if I'm going to sandwich this device, I can even more reduce the effect of short channel device. So this type of a fabricated device is called by the name Delta. It's called as Delta MOSFET. Delta means depleted lean channel transistor. So it is based on the concept of SOI double gate. So silicon on insulator double gate. It was in short called as depleted lean channel transistor, which is called as Delta, where the device is made in a tall and a narrow silicon island called finger, leg or fin, as shown in figure 4.25. So usually you see here, this height will be very, very small compared to the substrate height. But here, since the height of the device is very, very large compared to the substrate height, this looks like a leg or fin. It is looking like a leg or fin. That's why this device is called as a FinFET. Or in technical terms, it is called as a Delta MOSFET. You have a depleted lean channel transistor. Okay. The FinFET is similar to a delta, except for the presence of a dielectric layer called the hard mask on top of the silicon fin. So see this diagram and the previous diagram, everything is going to be same, but here I am going to have a hard mark. You can see the width of the gate is reduced, but here you see the gate width is very high, and here in between the gate and source you have an insulating layer. In that you will be having a hard mask. That is the difference between FinFET and a Delta MOSFET. See, first we have seen what is dual gate MOSFET. The conventional all MOSFETs are called dual gate MOSFET because my substrate is considered to be another gate terminal. Okay, and one modified version of double gate MOSFET is going to be Delta MOSFET, which we have seen here. And one slight variation of Delta MOSFET is going to be FinFET, where I'm going to have a hard mask between the gate and source terminals. Okay, this hard mask, what is the use of hard mask? It is to prevent the formation of parasitic inversion channels at the top corners of the device. So it ensures that the channel performs very good and prevents the formation of parasitic channels. So the channel is embodied in a fin sitting above the insulator in a wafer plane, SOI wafer. So you have a channel which is sitting above the substrate. So usually the source and drain, everything will be covering the entire length and width of your device. But in that, you can see the source and drain are separately protruding outside the device. It is looking like a leg or fin, right? So that is the reason why it is called as Finfet. And you can see a channel is between source and drain. So it is available inside the fin. The channel is sitting pretty much on a silicon on insulating wafer. The SI silicon fin is either undoped or lightly doped. The gates of FinFET are formed by wrapping the gate material around the sides of silicon fin. So you have between source and drain, you have a silicon fin, and I'm going to wrap the gate around this silicon fin. You're able to visualize. So if I remove this gate, I'll be having a silicon fin with a hard mask. And that silicon fin is going to be either lightly doped or it is going to be completely undoped. That is left to the fabricator's choice. Okay. And above that silicon fin, I'm going to fabricate a gate layer. So it is looking like the gate layer is wrapping your silicon fin. So if you remove the gate layer, you can visibly see the SISO silicon fin inside the between the source and the drain terminals. So initially, FinFET and Delta transistor, everything is going to be same, but later on they distinguished the usage of Delta and FinFET. So initially, see here, the FinFET was initially named as Delta transistor, but finally it has been renamed as FinFET. So Delta transistor is without having this hard mask. If you have a conventional silicon between the source and drain, and between the source and gate, it is called as delta. Delta is depleted lean channel transistor. But what we are seeing is if you are going to apply a hard mask and you are going to wrap the gate around the silicon fin, I'm going to have a new device which is called as FinFET. So initially they say that Delta and FinFET were the same transistor, but later with the FinFET having a major difference between the structure between the in comparison with Delta, then they started calling Delta transistor whenever they use that structure and FinFET whenever they are using the structure for